Alright, this topic is taking the quadratic formula and applying it. And when they ask for an exact answer, it probably goes against your intuition if you're kind of new to this quadratic formula thing, but you're going to leave the answer with your square root simplified. You're not going to punch the square root into the calculator and get your two answers. You're going to leave it probably what you would consider as looking ugly. But to have an exact answer, you have to leave the square root as it is. If you take your calculator and evaluate the square root, you're rounding it off, and so your answer isn't exact anymore. So whenever they say exact answers, plan on probably having a square root in your answer, and there's nothing you can do about that. Alright, let me just write down the quadratic formula. It's the opposite of b, plus and minus the square root of b squared minus 4ac all over 2a. And remember that we get these a, b, and c values by having a quadratic equation written in what they call standard form. So standard form is a little bit scary. It looks like this, but generally it just means that you have 0 on one side and all your x squareds, x's, and numbers on the other side. And we're hoping there's a number here, could be an invisible one, a number here, and a number here. And that's how would we get our a's, our b's, and our c's. So let's try one together. 5x squared plus 6x minus 7 equals 0. Put this down in your notes. Make sure you have your quadratic formula written on the top. If I'm going a little too fast and you need to hit pause, then go right ahead and do that. I also want to add that this is not a factorable equation. I've tried it before. I'm not going to do it out now to show you how I'll hit a brick wall on that. But this is not factorable, so we're going to use the quadratic formula. So the first thing we need to do is write down our a's, our b's, and our c's. Our a value is the one in front of the x squared, so that's 5. The b value is the one in front of the plane x, so that's 6. And our c value is not just 7, but it's negative 7, because that negative sign is married to it. So now we just plug in everything. The opposite of b, since b is 6, our opposite is negative 6. Plus and minus. B squared, it's going to be 36 minus 4 times 5 times negative 7 all over 2 times 5. Okay, negative 6 plus and minus 36 minus 20. 20 times 7 is negative 140. Boop, boop. Notice I have a minus and negative. All over 10. My neighbor's using a saw. I'm outside, so sorry if it's really loud. Hope you can still hear me. I'm a lot closer to you than they are. Alright, negative 6 plus and minus. What is 36 plus 140? It's 176. All over 10. So, we're almost done. The only thing that we need to make sure is that we do have the radical or the square root simplified, and there'll be another video that you can go look at called simplifying square roots, because there's a rule out there that the math police enforce that if you leave a perfect square inside a radical, they'll come and they'll just like haul you off and take you to math jail or something like that. And you definitely don't want that to happen. So I'm going to think about some perfect squares that might divide evenly into 176, and I'm thinking 4 goes into it. Let's see, if I put 4 into 17, it goes in 4 times with 1 left over. Yes, 4 times 44 is 176. But if I carry this out a little bit more, and I try 16 going into 176, 16 goes into 17 once with 1 left over, so 16 times 11 also gives me 176. So what I'm going to do now is I'm going to write negative 6 plus and minus, and I'm going to just do this one simplification out. I won't for the next problem, but just in case it's been a while since you've done this. I just rewrote 176 as 16 times 11, and now I know that the square root of 16 is 4. So I'm rewriting it like that. I'm just slowly replacing things as I go along. I'm going to slide it up just a tad. And now what I need to do is I need to see if I can reduce. I can't touch the 11 because it's under the square root, but if there's a number that's common to the negative 6 and the 4 and the 10, I have to reduce that. And you notice that they're all even numbers, So I can reduce all those by 2. So negative 6 divided by 2 gives me negative 3. 4 divided by 2 gives me 2. The square root of 11 stays the same. And 10 divided by 2 gives me 5. So I'm just going to write it nice and clear over here so that you can see it. So this would be my final answer. It is exact because I haven't estimated the square root of 11. It's also exact because I cleaned up the square root of 176. I didn't leave that with any factors that are perfect squares in there. And I have reduced my fraction, so it's exact. Alright, let's go through the process with a different equation. Let's see, how about we try, we'll try some with smaller numbers. I'm not positive. Alright, so x squared plus x minus 1 equals 0. Alright, so what we want to start off with is our A and our B and our C. And again, you better have written down that problem that we just did, and you better have that quadratic formula right at the top of your notebook page, because I'm not writing it down again. Alright, so you can use that as a model. Alright, our A value is the number in front of x squared. It's an invisible 1. The B number is the number in front of the x, which is also an invisible 1. And our C value isn't just 1, but it's negative 1. Alright, now we need to put it into the quadratic formula. So the opposite of b will give us negative 1, plus and minus square root of b squared, 1 times 1 is 1, minus 4 times a times c, all over 2 times a. Alright, so now we want to start our PEMDAS, or order of operations work. We're going to leave the negative 1 plus and minus the same and start cleaning up under our radical. 1 minus, what's 4 times 1? That's 4. 4 times negative 1 is negative 4. So we have 1 minus a negative, boop, boop, all over 2. And that's going to equal negative 1 plus and minus. 1 plus 4 is a happy little 5. This one's a lot easier. There's no perfect square under 5. There's no, the only factors of 5 is 5 and 1. So we can't touch that. There's also no reducing to do. So we are absolutely done. This one was a happy one to stop on. There's nothing left to do. It is exact. And if they wanted you to estimate or approximate an answer, you would grab your calculator and get out of it whatever square root of 5 is and keep going. But we're done with that problem. Nice and easy. Let's try another one. Alright, for this example, if you're feeling brave, why don't you copy it down, hit pause, work through it, and then hit play. If you want to walk through one more with me, that's absolutely fine. We're going to do another one together in just a minute after this one. So let's try x squared plus 5x minus 14 equal, whoops, I don't care if there's any notifications, equals 0. Again, where do we start? We need our a's, we need our b, and we need our c. A value is the one in front of the x squared, it's 1, b value is 5, and c is negative 14. Now we need to plot those into our quadratic formula. So the opposite of b, plus and minus. B squared will give us 25 minus 4 times a times c, all over 2 times a. Now we need to apply our order of operations. Underneath the square roots where I work first. 25 minus, what's 14 times 4? I'll do that over here. 4 times 4 is 16. That's going to be negative 56. Boop, boop. All over 2. Negative 5 plus and minus. 25 and 56. 1. That'll be 8. Oh, nice. Hopefully you know why I said nice. Because we have a square root of 81, and 81 is a perfect square. So our exact answers aren't going to have anything to do with square roots, because now that we know the square root of 81 is 9, we can follow through and do what we normally do. We're going to have one solution that's negative 5 plus 9 over 2, and the other solution is going to be negative 5 minus 9 over 2. Alright, back up to this one. Negative 5 plus 9 is 4 over 2, which comes out to be 2. The bottom one, negative 5 minus 9, is negative 14 over 2 equals negative 7. 2 roots, exact. No square roots at all, because we took the exact square root of 81. Alright, one more. Again, this one I would really suggest you try to hit the pause button, copy it, and give it a whirl on your own. Alright, leave some room here. Let's try x squared plus x minus 3. Okay, hit that pause button and carry on. So a is 1, b is 1, c is negative 3. Applying the quadratic formula, the opposite of b, plus and minus, square root, b squared minus 4 times a times c all over 2 times a. Starting to clean them up. Negative 1 plus and minus 1 minus negative 12 all over 2 equals negative 1 plus and minus square root of 13. And that's all you can do. There's nothing else you can do to have it as an exact answer. The 13 can't be simplified because the only factors of 13 is 13 and 1. And there's no fraction. There's no reducing of any kind of a fraction there. So we're all set. I hope that helped. If you have any questions, come find me and I'll clarify for you. Thanks.